All right, well, welcome back. We're going to kind of use two topics today. Our first topic is going to be average value, and the second topic that we'll hit will be properties of integrals, specifically even and odd functions. So let's attack this graphically first. Let's go ahead and sketch out a nice function. We'll say it starts here at A. Just kind of real nice and even, hopefully. And we'll say it ends here at B. Let's say it ends up reaching a height of 4. So the question is we want to find the average of this function. And if you think back to pretty elementary math, if you want to find an average, you take all your numbers, you add them up, and divide by however many you have. But we can't do that on a function because there's an infinite amount of points. So let's draw in a line that's going to represent the average of our graph. And let's see, I'm going to say it maybe right about here. Now, what am I implying by this? Well, let's go ahead and label this average value. I'm implying that the area under the curve, this whole section, is equal to the area of this rectangle. And it kind of looks like maybe this piece and this piece make up this amount. I'm kind of just eyeballing it here. But again, I'm trying to show that this average value would represent the area of the rectangle, which is equal to the area under this curve. So let's go ahead and write that out kind of in English, and then we'll put it into some calculus notation. I'm saying that the area under the curve is equal to the area of the rectangle. All right, now let's translate into calculus. To get the area under the curve, well, I would just integrate from a to b, lower bound to upper bound, of this function, which I'm just going to call f of x dx. Now think, third grade math. How are you going to get the area of the rectangle? Well, hopefully you're saying it's base times height. Now, in this case, I don't know if this base here has a base of 5, 10, 15. All I know is to get that distance, I would have to do b minus a. Okay, so I'm going to say I have a base of b minus a. And the height of this rectangle that we drew is this blue line here, which we call the average value. So I'm going to say it's b minus a times the average value. Okay, so again, this will get me the area under the curve when I integrate from a to b. And I'm describing my rectangle as the base, which is b minus a, times a height of the average value. Now, if my goal was to solve for the average value formula, or write this as the average value, all I would have to do is get rid of this b minus a by dividing it over. And we've got our formula. The average value formula, so average value, is equal to the integral from a to b of f of x dx divided by b minus a. Now, most books are going to rewrite that as 1 over, they'll pull out as a coefficient, 1 over b minus a, integral of a to b of f of x dx. Alright, so let's box that in. This is your formula for average value. Alright, so let's go ahead and try a problem. Find the average value of the function f of x equals 3x squared minus 5 on the closed interval -1 to 2. So basically, we've just got to memorize that formula. To get the average value, formula going through our head, whoopsie, should be 1 over b minus a, integral from a to b, of my function f of x dx. Alright, so now I'm just going to put it in terms of the problem. These will tell you your a and b. So that's a, that's b. So I'm going to say it's 1 over, and I'll write it in here. You can do this math in your head. 2 minus -1. The integral from -1 to 2, 3x squared minus 5 dx. And at this point, we have just a nice easy integral, nothing fancy, no u sub. So this is going to get me a 1 over, those of course turn into a 3. Go ahead and integrate this. X cubed minus 5x. Plug in your bounds. And again, just make sure you multiply that final answer by 1/3. Got my 1/3. 8 minus 10, I believe, and -1 plus 5. I've got my 1/3, -2 minus 4. Looks like I get an answer of -2. All right, now let's see what this means graphically. Let's go ahead and make a quick sketch of that original function, 3x squared minus 5 on our closed interval, -1 to 2. So I'm going to real quickly plug in -1, and -1 gets me a height of -2. I'm going to plug in a 2, which gets me a height of 7. So those are my endpoints. I'm going to plug a few more numbers in. At 1, I'm at -2 again. At 0, I believe I'm at -5. And I'm just going to connect those, not going past the endpoints, of course. So basically what we're saying is, though, even though there's a chunk above the x-axis, there's much more area below the x-axis. So when you add these pieces together and divide, you should be getting a negative number. So we certainly can have an average value of a negative value if more of the function is sitting below the x-axis. Okay, in this example, we're going to solve an average value problem graphically. So instead of a function to actually integrate, they do call this f of x, so I am going to go ahead and label this f of x. But you notice I don't have an actual function to integrate itself. So it does say find the average value. So you just got to be aware of that wording, catch it, on the closed interval -8 to 6. So that's my a and that's my b. So remember, that's 1 over b minus a, 6 minus -8, integral from -8 to 6 of my function f of x dx. Okay, so hopefully we put these two together to make it a plus sign. So I've got 1/14, the integral, which means I need to take all the area from -8 to 6 and add it all up. So again, I just take your time, go through and get everybody's area. You can break it up into nice little sections. I'm going to use that square and triangle. I'm going to do, you'll notice this is a quarter of a circle. You could go trapezoid, you could break it up into a rectangle, into triangles, and then a triangle over here. But take your time and first fill all those values in. Alright, so I've got all mine labeled in there. Hopefully yours came out the same. And just watch the bounds. We are going from -8 to 6. So I'm going to go from this end only up to 6, add those areas together, and I'm going to cancel things that I can. This makes -6, so that should cancel with this +6. This -3 should cancel with this +3. So it looks like I basically have 1 plus 4 pi. And I'm going to multiply that by 1/14. So I would just say I have 1 plus 4 pi all over 14. And hopefully a pretty friendly question. Okay, so just watch that term average value and watch that 1 over b minus a formula. Alright, our next example here is a pretty common multiple choice question. So you'll notice they don't come out and actually use the words average value anywhere. They say on the closed interval 1 to 5, which of the following could be a graph of f with the property 1 over 5 minus 1, integral from 1 to 5 of f of t dt equals 2. You've got to be smart enough to recognize when you see that 1 over b minus a, your upper bound is b, your lower bound is a, and you're staring at b minus a. So they're giving you the average value formula. So I'm basically going to rewrite this off to the side. Okay, I'm recognizing it as average value. And I'm saying, okay, they're really saying 1/4 of the integral, or the area under the curve, has to equal 2. So here's what I'm doing. And again, just another way to look at it, I could go through each one and take 1/4 its area to see what gives me 2. Or maybe even do this. I could multiply both sides by 4. So basically the area under the curve has to equal 8. Or like I said, go through and see which one has 1/4 the area to get you to 2. So I'm going to start with the easiest to me, and that would be this rectangle here. And I'm just going to draw in my area under the curve. And if I take a look at it, looks like a height of 3 and a base of 1, 2, 3, 4. That clearly has an area of 12, and I'm looking for an area of 8. Probably the next easiest one to integrate, maybe this trapezoid here, or perhaps these two triangles here. You can add that together. Now, on this first example, A here, I can't actually integrate this thing with a geometric shape, so I'm just going to draw in a shape that I think is the closest to its area. And I'm going to put in a triangle here and kind of guess what my area is at this point. So basically this triangle has a base of 4 and a height of 4, so I'm going to say that triangle itself has an area of 8. Now clearly there's more to it than 8. There's all this piece here and this piece here. So I already know that answer is greater than 8, so I'm going to X that one out right away. In part B, I'm going to do something similar. I'm going to, again, build a geometric shape, so I'm going to make a triangle. And since it's that same triangle with a base of 4 by 4, the triangle has an area of 8. And I actually want less than it because this is less than 8. So that's not going to be my answer either. We've already crossed off C. This is just a nice trapezoid. 1/2 base, height 1 plus height 2. Looks like a base of 4. My heights look like 1 plus 1, 2, 3, 4. So that's 2 by 5. That has an area of 10. So I'm hoping it's the last one here. That's 2 by 4, which is 4, and another one of 4 gets me an area of 8. Alright, so again, just a pretty common multiple choice question for average values. Alright, our next question on averages is going to have a few parts to it. So given this table here, you'll notice that they give us f of x, f prime, and f double prime. And our first question, A, says, what is the average rate of change of f over the interval -2 to 3? Well, you really got to pay attention to that word, average. Now that we have this average value formula, I think that's probably the most useful. So I'm going to set up my 1 over b minus a from a to b. Now, it tells you exactly who you're taking the average of. All right, so take your pencil and box in the words what it says average. It says average rate of change. And if you want a rate of change, well, that 4-letter word rate should give it away. A rate is a derivative, so I am integrating f prime of x dx. Okay, so let me run through this again. The average is telling you to use the average formula, 1 over b minus a, and you're doing it of the rate of change, which is the derivative. Now, I'm going to plug my notation into this problem here because I'm using -2 to 3. So I'm going to say it's 1 over 3 minus -2, the integral from -2 to 3 of f prime of x dx. So if I keep going, that's of course 1/5. Now you don't have an actual function to integrate, so be careful. Who do you take the derivative of to get f prime? Well, hopefully you're saying f of x, and we'll just use our bounds -2 to 3. So I'm going to get 1/5 upper f of 3 minus f of -2. And now I'm just reading my table. F of 3, here's my f, here's my 3, should hopefully be 0, minus f of -2, here's my function, here's my -2, 7, so I get an answer of -7/5. Part B, what is the average rate of change of f prime, the derivative of f, over the closed interval -2 to 4? So again, watch that silly word average, that's going to keep popping up on you. That's telling us 1 over b minus a, integral of a to b, and now read the next few words, they'll tell you who you want the average of. The rate of change of f prime. So let me say it again. I want the rate of change, which you should know means the derivative, and it wants the derivative of f prime. So you are really averaging f double prime, the derivative of f prime. And once you've got that, the rest should be pretty easy. So again, I'm using my average formula. Who am I averaging? The derivative of f prime. So that's f double prime. Plug the corresponding numbers in. So I've got 1 over 4 minus -2, -2 to 4, of f double prime of x. So that's my 1/6. When I integrate f double prime, I'm actually getting f prime. Plug in the correct bounds, -2 to 4. Remember to do upper minus lower. So I've got my 1/6, getting f prime of 4 minus f prime of -2. 1/6 of, I need to scroll back, I need f prime of 4 and f prime of -2. F prime of 4, here's 4, here's f prime, should be 2. F prime of -2 looks like 0. So let me scroll back here. Whoops, I lost my work here. F prime of 4 minus f prime of -2. We said it was 2 minus 0, so hopefully you've got a 1/3. All right, so here's a typical free response question, a part A, part B here. The velocity of an object traveling in a straight line is given by v of t. What is the average velocity? So watch that keyword average. Right away I'm setting up my 1 over b minus a. So here's my a, here's my b, so hopefully you've got 1/3 integral from 0 to 3. And who are you averaging? Read the next word, velocity. So the sine of pi over 2t, and of course dt. So it looks like we have to do a little bit of u sub to integrate this function. So I'm going to do my work off to the side. And hopefully you're going right along with me. Pi t over 2. du is pi over 2 dt. Therefore I get 2 over pi du equals dt. So I'm going to keep going. I've got my 1/3 integral 0 to 3. I've got my sine of u and 2 over pi du. I'm going to pull out my 2 over pi, so I actually have 2 over 3 pi. When I integrate sine of u, I get negative cosine of u. And I am now going to change my bounds, which I really could have done back here. So instead of 0, I'm going to plug it in here. 0 divided by 2 is still going to be 0. And when I plug in a 3, I'm going to end up with 3 pi over 2. So I'm going to have -2 over 3 pi, pulling that negative out. And my upper is going to be the cosine of 3 pi over 2 minus the cosine of 0. This gets me a 0 minus 1, so I basically have a -1. I'm going to scroll up just a little, and I'm getting positive 2 over 3 pi. -1 times this value turns it into a positive. So this is my average velocity of that function. I'm going to go get part B now. I see that word average again, so I'm going to my 1 over b minus a, integral of a to b. Now who am I finding the average of? Well, it says it right there, acceleration. All right, from 0 to 3. So I've got my 1/3, 0 to 3. Now they don't tell you acceleration, so you actually can go get it. To get acceleration, I'm just going to take the derivative of velocity. So I've got pi over 2 sine of pi over 2t dt. Now I don't have too much work to do here because I already know when I integrate, acceleration here, I'm going to get velocity. So I have 1/3. I'm just going to get that velocity function from 0 to 3, which was the sine pi over 2t. Whoops, and my bad, this should have been, that should have been cosine when I took the derivative. Sorry about that. And now just plug in my bounds. So I've got upper minus lower, so the sine of 3 pi over 2 minus the sine of 0. So that's my -1 minus 0, looks like a total of -1/3. So there you have it. Those are our notes on average value of a function. So our goal tonight is that 1 over b minus a, integral a to b of your function. Okay, our last few minutes, we just want to revisit the definitions of even and odd functions. So hopefully you recall, if a function is even, it is symmetric to the y-axis. Okay, the easiest even function is a function with an even exponent. For example, y equals x squared. Okay, if my exponent is even, it's an even function. So if I make a quick sketch of x squared, hopefully you can clearly see you're symmetric to the x-axis, or I'm sorry, to the y-axis. Now, what happens to be really great about even functions is that if you're integrating, let's say from -2 to +2, basically I can just integrate from 0 to 2 and multiply that function by 2. Kind of just a quick shortcut that'll come in handy if you know your function's even. Even a better shortcut is if your function's odd. That's even more handy. Oops, I'll move that up there. So again, if your function is odd, you are symmetric to the origin. All right, we always stress odd and origin go together. So the easiest odd function is probably an odd exponent, for example, x cubed. Again, if my bounds go from -2 to +2, basically this piece and this piece, hopefully you've guessed it already, are going to cancel. They're symmetric, so they're the same distance, and this has a negative value where this has a positive value. So if you can tell if a function's even or odd, you're saving yourself a lot of time. Alright, so given f of x is an even function, and we know 0 to 3 of f of x is -4, and -7 to 0 of f of x is 6, we need to evaluate these. So the first one I hope is pretty straightforward. My bounds match 0 to 3, 0 to 3. The only difference is these are opposite because these are backwards. So hopefully you can just pull out a negative and actually make this a +4. Which I think I just got ahead of myself. I think I totally disagree with that, and this should be a -4. And let me be more specific. The whole key to this is that the function is even. So I'm going to draw this out below before we get a little too carried away. So let's go ahead and mark 0 on the number line to 3. And 0 to -7 here. And I'm going to put some brackets on just to describe what they're saying. They're saying from 0 to 3, this section is -4. And they're telling me from -7 to 0, this section is 6. Now the whole key was that this function is even, so really from 0 to -3, this section better also be -4. I better be symmetric to the y-axis. So again, I don't want to say this answer is +4, in fact it really should be -4, even though, and the bounds are actually in the correct order. I think I was losing my mind momentarily. So it should be -4 from -3 to 0. Part B wants us to evaluate the integral from -7 to +3. Okay, well let's do a little math. Since we now know this section is -4, to get the distance from -7 to -3, I'm going to take this big bracket and subtract the small bracket. So 6 minus -4, hopefully you'll agree this section should be a +10. And lastly here, if this is symmetric, then I know out to +7, this little section should also be +10 because this whole thing also needs to be 6. So when I integrate from 7 to 3, I do have to admit the bounds are in fact backwards this time, so I'm going to pull out a negative and I'm going to pull the 2 out and integrate from 3 to 7 of f of x dx. So if I look from 3 to 7, that has an area of 10, and I'm multiplying that by -2, so hopefully we've got an area of -20. Alright, well that completes our notes tonight on average value and even and odd functions. We look forward to seeing you tomorrow.